The following is an encore presentation of Everything Everywhere Daily.
All around you, in the air and the ground, is the most common element on Earth, oxygen. As you are certainly well aware, oxygen is required for life on Earth as we know it. But you might not realize that the Earth didn't always have oxygen in its atmosphere. Oxygen has been responsible for everything from the rise of multicellular life to the space program. Learn more about the element oxygen, what it is, and how it came to be in our atmosphere on this episode of Everything Everywhere Daily. This episode is sponsored by NerdWallet.
Nerds!
When it comes to general knowledge and history, you know I've got you covered. But who do you turn to when you need smart financial decisions? If your answer is NerdWallet, then you're absolutely right. And if it's not, let me change your mind. The nerds at NerdWallet have spent thousands of hours researching and reviewing over 1,300 financial products. And they have the tools you need to make smarter financial decisions. Looking for a credit card? Go beyond the basic comparisons, filter for features that matter to you, and read in-depth reviews. Ready to choose a high-yield savings account? Get access to exclusive deals and compare rates, bonuses, and more. House hunting? View today's top mortgage rates for your home sweet home. Make the Nerds your go-to resource for smart financial decisions. Head to nerdwallet.com/learn more. NerdWallet. Finance smarter. Disclosure. NerdWallet Compare Incorporated, NMLS 1617539.
What do Mattel, Banana Republic, ButcherBox, and Glossier all have in common? They power their businesses with Shopify. Shopify is the most innovative and scaled commerce platform on the planet that also happens to have the best converting checkout on the planet. And that's no industry secret. That's Shopify. Learn more at shopify.com/enterprise.
Before I get too deep into the discussion of oxygen, I should probably explain what oxygen is and what makes it so special. Oxygen is the 8th element on the periodic table. It also has the distinction of being the 3rd most abundant element in the universe after hydrogen and helium, and the most abundant element in and on the Earth itself. Oxygen is almost twice as abundant as silicon in the Earth's makeup. What makes oxygen so special, and what you're going to need to understand to make sense of the rest of the discussion on oxygen, is that it's very reactive. Oxygen's outer electron shell has 6 electrons out of a possible 8. Atoms really want to have full electron shells, and they can do this by bonding with other atoms and using their electrons to fill up that outer shell. Oxygen is actually one of the most reactive elements on the periodic table. When oxygen reacts with something, it's called oxidation. And, just to be technical, oxidation has a more general meaning as well. If an atom gives up electrons, it's being oxidized, and if it gains electrons, it's called being reduced. In a strict chemical sense, you don't need oxygen in an oxidizing reaction, but the name comes from reactions using oxygen because it was the first known oxidizing reagent. And this episode is about oxygen. You're probably familiar with many forms of oxidation. Rust is a form of oxidation. Burning and combustion are forms of oxidation. If you've ever seen an apple or a piece of fruit turn brown, that's because it's reacting with oxygen. So oxygen, in addition to being responsible for life as we know it, it's also responsible for decay and destruction. Oxygen in the atmosphere is almost never in its atomic form. Instead, it tends to bind to itself to form oxygen molecules. This is usually in the form of O2, which is just 2 oxygen atoms bound together, or sometimes O3, which consists of 3 oxygen atoms and is called ozone. If we go back far enough, there was a time when the Earth's atmosphere had almost no oxygen in it. The atmosphere mainly consisted of gases such as methane, ammonia, and water vapor. The microbial life forms on this planet at that time were all anaerobic, meaning that they didn't use oxygen. Then about 2.4 billion years ago, something happened. A form of life developed known as cyanobacteria, also known as blue-green algae, which could conduct photosynthesis. These cyanobacteria consumed carbon dioxide and gave off oxygen as a byproduct. This began what is known as the Great Oxidation Event. The addition of oxygen to the atmosphere didn't really do much at first. Given how reactive oxygen is, it would bind itself to rocks and other organic matter, quickly removing it from the air. However, over time, as cyanobacteria spread and the rocks around the world became fully oxidized, oxygen began to accumulate. And this was not good news for the microbes, which were adapted to a reducing atmosphere with methane and ammonia. This is why the Great Oxidation Event has also been called the Great Oxygen Catastrophe and the Oxygen Holocaust. It resulted in the death of most life forms that existed on the planet at that time. Over the course of several 100 million years, more and more oxygen accumulated in the atmosphere, which resulted in more life forms that were adapted to oxygen. Aerobic metabolism, which uses oxygen, is more efficient at the production of adenosine triphosphate, or ATP, which is the primary molecule used for energy in cells. The Great Oxidation Event may have also resulted in the creation of eukaryotes, which are the cells that have a nucleus and are the basis of multicellular life. Oxygen in the atmosphere kept increasing over a period of hundreds of millions of years. Today, the percentage of oxygen in the atmosphere is approximately 21%. However, there was a time when oxygen levels reached 35% at the end of the Carboniferous period, which was about 300 million years ago. A world with an atmosphere of 35% oxygen would be a very different one than the world we live in today. For starters, you could probably breathe in that environment for at least a little while. However, over an extended period, you'd probably suffer from oxygen toxicity, a condition normally only encountered by deep sea divers. This oxygen-rich world allowed for the development of enormous insects. Insects don't have lungs for gas exchange. They have to rely on the direct exchange of gas through their bodies. When oxygen levels increased, it allowed for more oxygen to be consumed by insects, which resulted in larger body types. The largest insect that ever existed lived in such a high oxygen environment. It was a dragonfly-looking insect with a wingspan of 27 inches or 68.5 centimeters. A 35% oxygen atmosphere would also have seen an enormous amount of fires. Combustion takes place much more easily in an oxygen-rich environment. These fires may have resulted in the rich layer of carbon in the ground from which the Carboniferous period gets its name. Oxygen continues to exist in the Earth's atmosphere because of plant life, which is continually creating it. If all of the living things in the world were to disappear instantly, the amount of oxygen in the atmosphere would actually start to decrease over time. Organic matter would decay, pulling oxygen out of the air, and geologic processes would remove oxygen as well. The estimated amount of oxygen in the atmosphere would be down to just 5% within 1.5 million years and down to 0.5% within 2 million years. This is why astronomers look for signatures of oxygen as a potential biomarker for life on other planets. Any planet with an oxygen-rich atmosphere would have to have some means of replenishing the oxygen, as, over time, all of it would eventually react with rocks and other chemicals. While oxygen has had a pivotal role in the creation of life on Earth, humans actually had no clue that it even existed for thousands of years. There were philosophers who believed that there was something in the air which was responsible for life. The 17th century Polish scientist Michael Sendivogius called it quibus vitae, or the food of life, and went so far as to identify it as the gas that was given off when potassium nitrate was heated. That gas was oxygen. Over a century later, in 1772, the Swedish chemist Carl Wilhelm Scheele created a substance called fire air by heating various substances such as mercury oxide. It was the only substance he could find that would support combustion rather than extinguish it. In 1774, the English scientist Joseph Priestley discovered what he called dephlogisticated air. However, it was the French chemist Antoine Lavoisier who figured out that the substance that Priestley and Scheele discovered was in fact a new element. He dubbed the new element oxygen, which came from the Greek words oxys, which means acid, and gens, which means the creation of. Lavoisier mistakenly thought that oxygen was a part of every acid. In 1877, the French chemist Raoul Pierre Paquet liquefied oxygen for the very first time, even though he only managed to create a few drops. Oxygen doesn't become a liquid until it reaches a temperature of minus 182 degrees Celsius or minus 297 degrees Fahrenheit. In 1891, the Scottish chemist James Dewar managed to create enough liquid oxygen to actually study. It turned out that liquid oxygen exhibited properties that weren't expected given how gaseous oxygen behaves. For starters, liquid oxygen isn't colorless. It actually has a light blue color. You can see videos online of experiments using liquid oxygen where you can clearly see its bluish hue. The other amazing property of liquid oxygen, and this is one that nobody expected, is that it's paramagnetic. It doesn't act as a magnet per se, but external magnets can influence it. Liquid oxygen turned out to be extremely useful. For starters, you can have a lot more oxygen in liquid form than you can in gaseous form. Oxygen has an expansion ratio of 861 to 1, meaning that liquid oxygen will have 861 times more oxygen than gas at standard temperature and pressures in the same volume. There are many applications where you want to have pure oxygen. One of the biggest is in rockets and spaceflight. Rockets require combustion, and combustion requires oxygen. However, the higher up a rocket goes, the less oxygen there is, and when you're in space, there's no oxygen at all. The solution is liquid oxygen. Liquid oxygen plus some sort of fuel such as liquid hydrogen, kerosene, or methane can provide combustion and thrust even in a total vacuum. Pretty much every liquid-fueled rocket, including the Saturn V used in the Apollo program and the Space Shuttle, have used liquid oxygen. Liquid oxygen can also be used for industrial purposes, mostly just as a convenient storage and transportation vehicle for pure oxygen. Pure oxygen can aid in combustion when something needs to burn hotter or more efficiently than just using the oxygen and air. The biggest single commercial use for oxygen is in the production of iron and steel. A jet of pure oxygen is injected into molten iron, which then removes impurities. Another big user of liquid oxygen is in the chemical industry, where pure oxygen is used to make various chemical compounds that include oxygen. Another big use of pure oxygen is in cutting and welding applications. A stream of pure oxygen can create a hotter flame, making it possible to cut and weld metals. The application that most people are probably familiar with is the medical use of oxygen. Supplemental oxygen is often given to people who have pulmonary or circulatory diseases where not enough oxygen is able to get into the body. By breathing oxygen with a higher partial pressure than the atmosphere, more oxygen is able to get into the blood. High-pressure oxygen treatments are used on people who've suffered from decompression sickness or carbon monoxide poisoning. By putting them in an environment with more oxygen, it's possible to displace the carbon monoxide that's been bound to the oxygen receptors in hemoglobin, the molecule that transports oxygen in the blood. In the case of decompression sickness, high-pressure oxygen can help redissolve nitrogen bubbles in the body, which occurs usually when scuba divers ascend too rapidly. Supplemental oxygen is often used by mountain climbers who climb peaks like Mount Everest where there is very little oxygen at the top. Likewise, pilots in military aircraft will often use supplemental oxygen when flying at extremely high altitudes. In commercial aircraft, during an emergency, oxygen masks will often drop to allow people to breathe during a loss of pressure at high altitudes. The oxygen in these systems usually doesn't come from oxygen canisters, but rather is produced on demand via a chemical oxygen generator. These will usually consist of iron filings, which are mixed with sodium chlorate to produce oxygen. By using a chemical oxygen production system, it isn't necessary to have high-pressure tanks on board a plane, and you don't have to worry about the tanks leaking. One place that you've probably seen oxygen being used is on the sidelines of sporting events. Believe it or not, there's actually very little evidence to indicate that this does anything beyond a placebo effect, as there is a limit to the amount of oxygen that hemoglobin in your blood can support. Breathing oxygen can produce a euphoric feeling, which is probably the reason why people think it works. And it's also the reason why you sometimes see oxygen bars. I've seen these in several airports around the world. You literally sit down to breathe oxygen out of a tube for several minutes. It can produce a temporary euphoric feeling, but it really doesn't do anything beyond that. Oxygen is everywhere, and most of the major life forms in the world depend on it in one way or another. We use it for industrial purposes and in medicine, and one day its presence might even let us know that there's life somewhere else in the universe. And that's not too bad for a gas that didn't even exist in our atmosphere 2.5 billion years ago. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Benji Long and Cameron Kieffer. I want to give a big shout out to everyone who supports the show over on Patreon, including the show's producers. Your support helps me put out a show every single day. And also, Patreon is currently the only place where Everything Everywhere Daily merchandise is available to the top tier of supporters. If you'd like to talk to other listeners of the show and members of the Completionist Club, you can join the Everything Everywhere Daily Facebook group or Discord server. Links to everything are in the show notes.